Hey everyone, good evening, Ram Ram, good evening. Thank you Savai. Savai, are you from Rajasthan? तुम राजस्थान से हो क्या? कहाँ से राजस्थान में कहाँ से? पाली से? जोधपुर, अरे वाह। नमस्कार भाई, नमस्कार, सत श्री अकाल, आदाब और क्या है बाकी बाकी की ग्रीटिंग्स। रे 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 रुक जाओ रुक जाओ रुक जाओ। I have not seen any animations yet other than what we have seen so far. Okay, and you don't have to write that on the doubt panel यार. Come on. Okay. सर आप कहाँ से हो राजस्थान में? मैं ओरिजिनली कोटा से हूँ, बट अभी मैं कोटा में रहता नहीं हूँ. इनफैक्ट 2005 से मैं कोटा से बाहर हूँ. सर माई स्पीकर वॉज ऑन फुल वॉल्यूम एंड आई गॉट अ शॉक व्हेन यू सेड हाय. चलो भाई बढ़िया, अगली बार से ध्यान रहेगा. केम छो? अरे मजा मजा आता मैं केम छो. आई एम फ्रॉम जयपुर. ओके ओके राहुल सर. गुड टू नो. खुशामदीद ओए खुशामदीद. सर वेयर डिड यू स्टडी फॉर जेई? ऑब्वियसली फ्रॉम माय होम टाउन यार. सर संडे को फेस टेस्ट है, आपको कैसा लग रहा है? भाई मेरे को कैसा लग रहा है, मतलब मुझे थोड़ी देना है, तुम्हें देना है. सर डू यू हैव अ लैम्बोर्गिनी? अरे आई डोंट इवन हैव अ मारुति 800. आई एम गुड चिरंजीवी. आई डोंट इवन हैव अ मारुति 800. मैं अभी 2 साल पहले तो कार चलाना सीखा है यार. सर हैज केटीएम? ना ना ना, आई हैव जुपिटर टू व्हीलर. व्हाट इज योर सैलरी? हाँ हाँ, और भी पूछ लो सर, आपके कितने बच्चे हैं, आपकी वाइफ का नाम क्या है, और थोड़े से पर्सनल सवाल पूछो, है ना. सर आपका पासपोर्ट का नंबर क्या है वो भी बता दो. सर द इनिशियल वेलोसिटी ऑफ जैवलिन थ्रो बाय नीरज चोपड़ा वाज 105 किलोमीटर पर आवर. दैट्स क्वाइट पॉसिबल. यस. ठीक है चलो भाई, फर्स्ट ऑफ ऑल स्टॉप राइटिंग एनीथिंग ऑन द चैट बॉक्स नाउ. I mean it. Stop writing anything in the chat box. Absolute silence. Pin drop silence on the chat box, please, for a moment. I need to speak something. Okay, everyone. Yes, thank you. So now listen to me carefully, everyone. Listen. देखो कैसा है. There have been feedbacks coming from the backend team, from the operations team of Vedantu. Listen to me carefully. No, nobody will write anything in the chat box now. Please don't write anything in the chat box. Listen to me. Okay. So, everyone. Thing is, you guys are being requested. मैं personally requested. I'm personally requesting to all of you guys. You know that this is right now chat which is on, and then apart from the chat, there is a doubt panel where you ask doubts. Okay. There are certain things which you don't have to write on the doubt panel. Okay, means once this chat gets switched off, or when you are not able to access the chat, you are supposed to not write any greetings on the doubt panel. Please don't write any greetings. Don't say hi sir, hello sir, or any kind of greetings which are not basically academic. Please don't write anything on the doubt panel, because it technically becomes a doubt, and that becomes difficult for the class teachers because they are supposed to answer it. Okay, so please don't make class teachers' life difficult. Okay. Second thing, have faith on your class teachers. If you have certain doubts, please ask them. Don't directly say that please forward it to sir. Your class teachers are equally equipped and well educated people. In fact, probably more educated than me. They will be able to answer your questions 99.9%. I can say this with 100% surety. There are certain doubts which are related to what I'm speaking. So that time, they themselves will forward the doubt to me if they're not able to answer it. Okay. Point number one, no greetings or things which are not academic to be written on doubt panel of the chat. Okay. Second, nobody will directly ask the class teachers to forward it to the master teacher. And I would recommend personally that you follow this in each and every session of yours, not just physics, chemistry, and maths as well. Okay. Thank you. Thank you. So this is more like my lovely students. Okay. Thank you so much, guys. And before I switch off the chat, okay, you know that we speak at the end, obviously. Okay, we speak at the end, obviously. So we'll speak towards the end. Whatever doubts you have, I will answer that. Okay. Yes. So everyone, we have 4 class teachers today, by the way. Rishabh sir, Gautam sir, Rahul sir, and Ankit sir. Say quickly hi to your class teachers. They are the awesome people. They always help us out. Sir, I'm traveling on Sunday, so what about examination? Again, something that Suri sir is not the right person to answer. Okay, you should be speaking to your Sam about it. Okay. Okay. Cool. I will answer all these queries towards the end of the session. Apart from this. Okay. Cool. Everyone. Yes, Anshul, I will tell you that also. Okay. So guys, now switching off the chat on the count of 5. Stop writing anything in the chat box. 5, 4, 3, 2, and 1. No writing on the doubt panel now. Don't write anything randomly on the doubt panel. Okay, guys. So good news is we are today starting a new chapter. I had one of my favorites from mechanics. This chapter is one of my favorites from mechanics, called as circular motion. And this is basically second type of 2D motion. We have already seen one of the 2D motions. 2D means the motion which happens in a plane. Okay, does not happen on a line, does not happen in 3D space. It happens specifically on a 2-dimensional plane. Before this, we have studied a motion called as projectile motion, that is also known as a 2D motion, because that also happens on a plane. Right, guys? So this is our second type of 2D motion, circular motion. It is a lot of things you can predict or you can actually gauge just by the name of it, and a lot of things you might already be aware about. But what is this chapter about is something that I will keep on sharing with you all. Okay, basically there are, from henceforth there will be always 3 chapters which you have studied as basics. They will mostly keep on playing their roles. The first chapter was kinematics, second chapter is laws of motion, which is also known as dynamics, and third one is work, energy, and power. Now usually whenever any different type of motion that you will be studying, like this is circular motion, after this you will be, after some time you'll study something called as rotation motion, and things will rotate, and then we'll speak about oscillations also. In all these chapters you will find we first speak about the kinematics of the motion, where speed, velocity, displacement, time, and accelerations will be related to each other. Then we'll speak about the dynamics of the chapter. That means what are the reasons because of which the body is going to move in the certain type of motion. That means when a body will move in circular motion, why will it move in a circular motion? The force will be spoken about. Okay, and then we'll obviously sometimes speak about the energy during the motion. Okay, guys. So I hope things are clear so far. 3 things we'll be speaking about in this chapter: kinematics, dynamics, work, power, energy. Okay. So everyone, the agenda for today in front of you all. We'll be speaking about various different physical quantities that we want to define in this chapter: circular motion, and then we'll speak about something called as angular and tangential acceleration, and then we'll speak about radial and tangential acceleration. Actually, the second one is only angular acceleration, and then we'll speak about radial acceleration. So no need to write it second time. Okay, so it is angular acceleration we'll speak about. Okay, guys. So what exactly is circular motion? If you will take a hint, circular motion is the motion where an object is going to move in a circle. Okay. For example, the most easiest type of circular motion that we always think of is not ceiling fan. It's not the motion of your hand, the hands of the watch. They're not circular motions. Okay. But yes, having said that, the tip of the the tip of the blades of the fan, the tip of the blades of the fan. If you just focus on the tip of it, that tip is actually moving in a path which we call as circular motion. Okay. The better example of circular motion would be if you tie a stone on a thread, like thread line, and if you connect a stone on the end of it and you start making it move in a motion which is what we call as a circular motion. Okay. Motion of moon around sun, motion of any satellite around Earth, motion of moon around Earth, motion of any satellite around Earth, motion of electrons according to Niels Bohr. Niels Bohr gave a postulate about how atom looks like, and he explained how electrons exist, right? That motion of electron around the nucleus is circular motion. The motion of clothes in the washing machine, the motion of the clothes in the dryer of the washing machine is circular motion. The motion of anything which is being grinded in your mixer grinder is the motion which we call as circular motion. The motion of a stunt artist in a death well. You must have heard about a death well. Mauत का कुआं. Recently, Salman Khan ki movie was there. I do not remember the name of the movie, but do not even want to know that. Okay. So the motion of the stunt man when that person is moving in the death well is what we call as circular motion. Like there are n number of examples about the things which are moving in the form of circular motion around us. Okay. Now before we actually get to the core of the chapter, we need to actually define different type of physical quantities here. So what happens when a body is going to move in a circular path? You can see that when the body is moving, its motion is basically confined in a particular plane. Okay. And also its distance from a fixed point always remains constant. Right. So when the body is moving like this, at any instant, if I want to define its linear velocity at any instant will always be tangential to the path. This is something which I gave you an idea in the chapter of projectile motion only. That whenever we are tracing the path of a body and we want to know where exactly the body is heading at a given instant, just go on that point in the trajectory of the path where the body is moving. On that point, just draw a tangent. That will tell you at that instant where exactly the body is trying to go. Okay, may not be going always in that direction because the body's direction may change as it changes in parabolic motion also. Projectile motion also, the body is not going continuously in a straight line, right? So similarly, if you try to trace the linear velocity of the body when the body is moving in say anti-clockwise manner, this is called anti-clockwise manner. Okay, are you guys aware about clockwise and anti-clockwise manner motions? What is clockwise? What is anti-clockwise? Okay. Some of you are not aware about it, maybe. So we know that whenever we talk about the motion of a clock, okay, motion of clock means motion of the hands of the clock. If you will ever notice an analogous clock, not the digital one, obviously the analogous one, you will find that it's hands. Its hands, if you will try to look at them, you will find that the hands of the clock will always try to move in this manner, right? Means this thing will always try to go like this. The hand of the clock will always try to follow this path, any of the hands. So we call that fashion of motion as clockwise manner because it is following how clock hands are moving. So if anything goes opposite of that is what we call as anti-clockwise manner. Okay, guys? So this is clockwise. CW is clockwise, and opposite of that is ACW or anti-clockwise. So if we try to trace the velocity of a body which is moving in a circular path at any instant in its journey, the black circle that you see is basically the path. It is not actually an object. The object is only a teeny tiny particle. It's a teeny tiny stone, right? So this particle is actually moving in this anti-clockwise manner, and at different points when we try to trace it at A, B, C, or D, we find that its velocity is continuously changing, and that's what is supposed to happen in a two-dimensional motion. The body might change its velocity at any instant of time, right, everyone? The important part is when the body comes back to its original position A, then its displacement becomes zero, and in a way, if you will see, the body is still continuing to move in the same fashion. Means what? Imagine, for an example, right now, if you look at the ceiling fan of your own house, you will find that ceiling fan is continuously moving in the same manner. In my house, it is right now moving in anti-clockwise manner. I don't know in what manner in your house it is moving, but if you notice, either clockwise or anti-clockwise, but that direction remains always the same. It's not that when you switch it off, it starts moving in the opposite sense. So, in a way, if we look at circular motion, let me first give you this very, very important clarity about it. When we look at circular motion, there are only two possibilities: either clockwise or anti-clockwise. These are the two possibilities in which your body can perform circular motion. But if we try to look at it from the linear physical quantities, linear displacement, linear velocity, linear acceleration, then actually the motion is not very easily explainable. Like the example I gave you, when the body comes back to its original position, it suggests that the displacement of the body becomes zero, and that is true. When the body starts from A and comes back to A, its linear displacement becomes zero. But the body has actually not changed the direction of its sense of circular motion. The body is still moving in the anti-clockwise manner. It might go once again in another circle anti-clockwise manner and come back to A. Its displacement again becomes zero, but practically the body is still going in the same direction. By direction, I mean the angular direction, the angle that it is tracing. Because of that, guys, when we study circular motion, the complexities that this brings, the motion, is sometimes very difficult to explain and understand and visualize the motion from the linear quantities perspective, the straight line perspective, as in the quantities which we know from kinematics chapter, displacement, velocity, and acceleration. So hence we define parallel physical quantities. We will basically try to now look at motion into two senses. One is a straight line motion, okay, and the other one is the angular motion. The body is going to perform angular motions. So the angular physical quantities, let me present in front of all of you. So when the body is performing the circular motion, we already are aware about the basic understanding of it now. What we basically try to define are the three physical angular quantities called as angular displacement, angular velocity, and angular acceleration. So for our understanding, the name has been kept very similar, and their meaning and their understanding will also be very similar, but the only difference is now the body is not moving in a straight line, but probably the body will be continuing to move in the same sense. Clockwise, so clockwise, 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 clockwise. So that's basically like comparing a body which is moving in a straight line continuously. Okay, like a ceiling fan, continuously moving in clockwise sense, clockwise sense, clockwise sense. So after one circle, clockwise, two circles, still clockwise, three circles, still clockwise. So it is not changing the direction angularly. Straight line manner, it is definitely changing its direction. As you can see in this diagram, the linear velocity and displacement and acceleration probably are changing their direction at all the instants. Okay, guys, so let's one by one define these three physical quantities. Their symbols are there written. Angular displacement, the symbol is theta. Angular velocity, that symbol that looks like W is called omega. Okay, that symbol is called omega. Don't worry, you will be getting very, very well versed with these symbols because of this chapter. Okay, and third one is called angular acceleration, which is alpha. And guys, try to focus on the first quantity more because if you get the first quantity right, if you understand it right, the second and the third one will be very logically and very easily understandable. Okay, so everyone, let's focus on angular displacement represented as theta. So when your body is performing a circular motion, try to focus on this animation. It tells you that the start to end point, if you look at it, the radius of the circular path is actually tracing an angle. If you see that angle, right? That angle which is traced by the radius vector, and I would actually give a better name to the radius vector now. I will call it the position vector, because if you imaginarily join, the position of the particle with the center. So maybe your initial position of the particle was A and the final position is B. You try to trace its position by drawing a vector. So this is its initial position vector R, or R1 you can call it, and this is the final position vector, that is R2. Definitely the magnitude of R1 and R2 is same. but they're not equilaterals because they don't have the same direction, right, everyone? So this angle which is being traced out, okay, this angle which is being traced out is what we call as the angular displacement, because effectively the body is moving in angular manner. So the amount of angle that is traced out by its position vector in whatever time it takes. We are not concerned about the time when we are displacing the body when we are talking about displacement. So we simply say that the amount of angle that is traced by the position vector of the body which is moving in the circular path is what we call as angular displacement. Okay, I'll write my definition also. The angle traced out by position vector of the moving body is known as angular displacement. Okay, also known as, or rather also represented as theta. Okay, guys, this is what it is. And what is the SI unit of angle in the chat box, please? Anyone? What is the SI unit of angles? Thank you. It is not degrees, it is radians. So definitely I will tell you the SI unit also. Okay, SI units is radians. Are we all aware about this, that 180 degree is equal to how many radians? Thank you. Yes. So if ever the angle is given in any of these, we can always convert it. Okay, can you people tell me the dimensions? Let me see if you guys have seen this. Mr. Brahma, this chapter is circular motion, but it is as per Vedantu's curriculum has been put in the chapter of work power energy. Okay, so don't worry. So dimensions are nothing. It is a dimensionless quantity. And maybe जब रोली मैम ने तुम लोगों को पढ़ाया था वो chapter units and dimensions तब बताया या नहीं बताया? Angle is the only physical quantity which is dimensionless but not unitless. It is the only physical quantity which has units but does not have dimensions. Only physical quantity. इसके अलावा ऐसी कोई और quantity आने वाली नहीं है पूरे physics में. Refractive index is also unitless, dimensionless. This is the only quantity which has units but does not have dimensions. Angle and state मतलब solid angle and angle both. हमें physics में solid angle की जरूरत पड़ने वाली नहीं है दोस्तों. So don't worry. ठीक है. And what about the nature of it? Is it a scalar quantity or a vector quantity? So अभी के लिए सिर्फ लिख रहा हूँ, थोड़ी देर में एक्सप्लेन करूंगा that it's a vector quantity. Yeah, इसका डायरेक्शन सबसे इंटरेस्टिंग चीज होगी. Angular quantities का डायरेक्शन will be the most interesting thing that we are going to see. Okay, this I will explain in the next quantity. Both quantities will be easily understood. Okay, चलो switching off the chat once again in 3, 2 and 1. Okay, हाँ तो विधान मैं बोल भी चुका कि थोड़ी देर में एक्सप्लेन करूंगा. Okay, okay guys, so now pay attention. The next quantity is omega, called as the angular velocity. If you people understood the correlation between in kinematics between displacement, displacement, velocity and acceleration, the correlation here will now be straightforward. Angular displacement we understood, the amount of angle traced out by the body when it is moving, right? So what is angular velocity? How fast the angle has been traced out. And this is very easy to understand actually. There are 3 hands in your watch, not the digital watch, again the analogous watch, the one where 3 hands are there. The 3 hands don't move at the same rate. They don't cover the total 360 degree angle. The 360 degree angle is not covered by all the 3 hands in the same time, right everyone? So the second hand, it sounds like something which is not new, but the second hand, the one which tells you the amount of seconds in 1 minute, right? That hand actually moves the fastest. We all know that. By looks of it, we can tell it, right? And that has basically the highest angular velocity because it will cover the same angle fastest. It will take the least time, right? On the other hand, your R hand is the one which goes like 1 to 12 after 12 hours. So that R hand will give you the slowest of the velocity angular. In fact, it's very difficult to trace it, right? So point is your angular velocity, just like your linear velocity, is displacement per unit time. But this time the displacement is also angular displacement. Okay, so if you're talking about a good amount of angular displacement like 30 degree, 60 degree, 45 degree, 90 degree, 180 degree, the angle which is measurable, the big amount of angle, right? For that angle, the amount of time taken may be also good amount. So such angular velocities that you'll be finding will be called average angular velocity. But if you're talking about say fraction of seconds, 1 millisecond, how much the hands are moving, then it is very difficult to actually trace the amount of angle, trace the amount of time which is taken. So in that case, the velocity may not be negligible. Be going back towards calculus here. So in that case, we'll be talking about instantaneous angular velocity. Okay, everyone. So should be easy for you people to trace this now. The units of angular velocity, SI unit, will be radians per second. Dimensions will be, can anyone tell me the dimensions in the chat box? Dimensions, anyone? Yes, as you can see, angular displacement has no dimensions, but it is 1 upon t which has the same dimensions. That means m0, l0, t minus 1 or simply t minus 1. Is there any other quantity which has same dimensions? Any other quantity which has same dimensions? Exactly, frequency, not lambda, but frequency. Okay, and everyone, because of that, angular velocity is also called as angular frequency. It is also called as angular frequency because it is telling you the number of times the circle is covered per second. It is also telling you the number of times you are covering the circle in 1 second. That's why it is. Okay. Yes, how frequently the 2 pi angle is covered. And its nature, obviously, if angular displacement was vector, this is also a vector quantity. Okay, guys? Cool. Now, time to understand the direction. Okay, so switching off the chat so that we focus on the direction part of it, and it is very interesting. So try to think from logic. Try not to get carried away by your notion so far. We have actually learned 10% of the physics here, maybe less than that. So don't try to think from that only knowledge perspective. The knowledge is about to get broadened. Okay, so please look at it with a very open-mindedness. Okay, so is angular displacement a wavelength? No. Okay, angular displacement has no dimensions, no units. Sorry, has no dimensions, and units are also radians. On the other hand, wavelength is a length. Later on we'll study that. Its units are meters. So angular displacement is not meters. So guys, let's talk about the angular velocity's direction. Its direction is defined. It is not its direction. It is defined smartly to be the direction that is perpendicular to the plane of the circle. If the body is moving in the circle, then the direction of angular velocity will be perpendicular to that circle. Maybe the body is moving in this circle like this, and the direction of angular velocity is perpendicular to that circle. But sir, there is one more possibility if you are trying to define this as the direction. There is another possibility of a direction perpendicular to the circle, that is downward. So smartly, to talk about the direction of the angular velocity, we recall one law, one rule that we know called as right hand thumb rule. Right hand thumb rule. That means what? If you curl your right hand fingers If you curl your right hand fingers in the sense of motion, the body is moving in the circle. You try to curl your fingers in the sense of circle. Okay. So if I look at it like this, maybe a body is going anti-clockwise. I don't know whether it looks anti-clockwise to you or not. To me, it looks like this is anti-clockwise. And if I curl my right hand like this, so this is the sense in which the body is moving, and this is the direction of the angular velocity perpendicular to it. Okay. But what if it moves in the other sense? If it moves clockwise, then I will also have to turn my fingers clockwise. Okay, guys. So my thumb is now pointing downward. Okay. And by the way, whatever is the direction of angular displacement is also the direction of angular velocity. Remember, linear motion. If a body is moving towards east, its displacement is also towards east. Its velocity is also towards east. If a body is moving towards west, its displacement will also be towards west. Its velocity will also be towards west. So that simply means what? The direction of angular displacement is also perpendicular to the plane found by right hand thumb rule. Okay, everyone. Right hand thumb rule. And this is where things are going to get very interesting. Let me just complete point number 3 and 4 also. So if we speak about a body which is moving in a circle, okay, and say it is continuously moving with constant angular velocity, if this value is constant, okay, if your omega value is constant, then to cover a circle, the time that it will take always, the amount of time that it will take to cover one circle complete, 2 pi angle, will always be a fixed time. We define that time to be the time period. Okay, we define that time to be the time period. And the angle that will be covering in one complete circle will be 2 pi, 360 degrees. So the total angle covered will be 2 pi, and the time taken will be capital T, which is time period. So this is the correlation between angular velocity, you can say angular frequency, and the time period also. And we know that 1 upon T, okay, 1 upon T is what we define as the frequency. Frequency is represented by different symbols. You will find frequency being represented by n. You will find frequency being represented by nu. Okay, so frequency can be f, can be n, or can be nu. All the 3 symbols are for frequency. I don't want you people to scratch your brain over it. It's basically frequency. So 1 upon T becomes f. So angular frequency and normal frequency, they are related like this. Omega is 2 pi f. Okay, guys. Now let me come to the point which is going to actually bring the wow factor also. So everyone, I said that when the body was moving in a circle, say a body is trying to start to move from A, and the body. Okay, in fact, let me start this discussion from angular displacement perspective first. You will be amazed to know that. I'm sure you will like the overall concept of it. Okay, so let me insert a slide below. One more slide I've asked for. Yes. So guys, I said that whatever is the direction of angular velocity is also the direction of angular displacement, right? So everyone, this is the direction of angular displacement theta. Now people, if the body which is moving in the circle is starting from A, or when I say starting from A, it is already moving. When it is moving continuously, maybe it is going as per the arrows which are given, it is going in this manner, which according to the direction looks like anti-clockwise manner. So everyone, tell me in the chat box, when the body travels and completes one circle and comes to A, okay, when it completes one revolution, how much angular displacement it has? One complete revolution. What is the angular displacement it has? Can you people tell me in pi? Will it be 0 or 2 pi? That's my question. It will be 2 pi, right? Perfect. It will be 2 pi. Okay. Yes, angular frequency is also represented by omega. So everyone, now listen to me carefully. The body is continuing to move in the anti-clockwise manner now. After completing one circle, the body does not stop. It continues to move in the same manner. Covers one more circle. Covers one more revolution. What will be the angular displacement now? Will you call it 2 pi? Will you call it 0? Or will you call it 4 pi? Will you be calling it? Yes, exactly. It will be 4 pi. Why would I say that, guys? Try to correlate. Listen to me very carefully. Try to correlate it with a straight line motion in which your car or any object is moving in say x direction, covers a distance of 2 pi, does not stop, continues to move in the same direction. So in the same time, it will cover the same amount of displacement, right? Are you getting the whole point why we are defining the angular physical quantities? Because I told you that the body is still continuing to move in the same manner. In a way, it has not changed its direction. The body is moving in the circular path, anti-clockwise, anti-clockwise, anti-clockwise. So one circle, 2 pi, 2 circle, 4 pi, 3 circle, 6 pi, 4 circle, 8 pi. Are you guys getting the whole point? As the body continues to move, it keeps on increasing its angular displacement. Getting it? Right? In fact, to be very honest, this angular displacement vector after one circle, if I draw it, it is only this much. It is only this much. After one more circle, the angular displacement will become double. After one more circle, the angular displacement vector will become triple. After one more circle, the angular displacement vector will become 4 times. Are you guys getting it? Following it? That is why the direction of angular displacement has been defined very interestingly perpendicular to the plane. Are you guys getting it? That is why the direction of the angular physical quantities is defined to be perpendicular to the plane. Are you guys now getting why the angular displacement quantities, angular quantities have been given a specific direction, that is the direction which is not going to change as the body is moving. Okay, guys, this is not regular displacement. This is angular displacement. Are you getting it now? Yes, linear displacement, definitely. अगर यहाँ side में linear displacement भी लिखते हैं. Everyone, let's write down the linear displacement also here. What will be the linear displacement after one circle? What will be the linear displacement after one circle? 0. Linear displacement after two circle? 0. Third circle? 0. Fourth circle? 0. Fifth circle? 0. That is why we are not thinking from linear displacement. We are thinking from the angle that is covered by the body. The angle that is covered by the body. It is continuously moving. अरे भाई वो वेक्टर सिर्फ वर्चुअली वहां दिखाया है. मैंने बोला था अपनी पर्सपेक्टिव, अपना जो सोच है, अपना जो थॉट प्रोसेस का दायरा है, उसको ब्रॉडन करने का टाइम आ गया है. अब हमने स्मार्टली एक डायरेक्शन डिफाइन किया जहां एक्चुअली बॉडी मूव नहीं कर रही है. दिस इज नॉट एक्चुअली द डायरेक्शन ऑफ मोशन ऑफ द बॉडी. गेटिंग माय पॉइंट एवरीवन? सो इट्स अ स्मार्ट वे ऑफ रिप्रेजेंटिंग अ वेक्टर क्वांटिटी. नहीं, एंगुलर डिस्प्लेसमेंट का डायरेक्शन बदल सकता है इफ यू चेंज द सेंस ऑफ रोटेशन. अगर बॉडी क्लॉकवाइज जा रही थी, तुमने उसे रोक के एंटी क्लॉकवाइज भेज दिया. If you change the direction of sense of rotation, only then the direction of displacement will change. But it will either remain up the plane or it will remain down the plane. Okay? Is that clear? Got it? So anti-clockwise maybe same value रहेंगे numerically, yes. But if you are calling, say, अच्छा एक और चीज बता देता हूँ, switching off the chat for everyone now. So everyone, just for our understanding, if I'm defining this direction to be positive, then naturally the downward direction will become negative. There are only two possibilities, just like straight line motion. This direction positive, this direction negative. Okay? So usually, when we look at from a plane perspective, say if you're looking at it from this perspective, Everybody, take your right hand on the screen, put your right hand, curl the fingers in the anti-clockwise manner like this. Curl your fingers like this. That thumb point towards you. सब लोग ऐसे अपने fingers को curl करो कि thumb तुम्हारी तरफ आ जाए. That's called as anti-clockwise sense of rotation. The thumb is pointing towards you, which is basically telling you imaginarily the angular displacement vector is coming towards you. Okay, so that direction by convention, again by convention, तुम चाहो तो बदल सकते हो एक question के अंदर. This by convention is considered to be the positive direction of the angular quantities. This direction that is coming towards you, anti-clockwise sense. And clockwise sense will be a vector going inside. By convention, called as the negative sense of vector quantities, angular vector quantities. Is that clear? Give me a quick +1 in the chat box. Okay. Awesome. बहुत बढ़िया. Thank you. So now don't write anything. Conclude कर दीजिए सर for revision. क्या conclude करूँ? इतनी देर से जो समझा रहा हूँ वो तो सुनो पहले. Conclusion पहले सुनना है. हाँ. ठीक है everyone. So we understood the direction of angular velocity and now we'll speak about the correlation between linear velocity and the angular velocity. The actual motion direction of the body is given by the linear velocity only, where the body is heading to. Angular velocity and angular displacement and angular accelerations are basically our understanding to simplify the understanding of the motion. Okay, everyone. So have a look at this diagram. What is happening here? Yeah. So everyone, this is how the body is moving, and the sense of motion of the body on angular direction is anti-clockwise. The body which I'm talking about is moving in anti-clockwise manner. Means its angular displacement when you try to trace, you'll have to put your fingers in anti-clockwise sense and thumb is pointing upward. That is the direction of angular velocity. Also the direction of angular displacement, by the way. Okay. So everyone, this is where the body is at the moment practically. When some people are asking where exactly the body is, the body is actually here. The body which is moving in the circular path. For example, a stone which is connected to a thread, and you're making it move in the circle. So this is where your stone is right now. This is where the body is. And at this instant, its instantaneous linear velocity is heading towards this direction. After some time, when the body will move, or maybe body was here, the body's linear velocity was shown by another vector. So this was its linear velocity earlier when the body was here. Okay, maybe at some other point. And before that, if I want to trace the body was here. Before that, or maybe after some time, the body will be here. Right, guys? So what I'm trying to tell you, that maybe this is A, this is B, this is C, this is D, different locations of the body. The point is, guys, when the body say moves from A to B, any random location A to B, whatever be that value, the total angle we call the position to be P, A to P when we speak about. This is the angle which is traced out by the body or its radius vector. This comes out to be say delta theta. This is the angular displacement. Means the total angle, the covered angle by the arc AP is delta theta. And if I try to write this angular displacement, we can write it as r into delta theta. How do we write that? For some people may not be aware about it. So let me give you the clarity of that also. So everybody, when we try to define angle in general, the fundamental definition that you know from mathematics for the definition of angle is arc upon radius. The definition of angle is arc length upon radius. So if this is the angle that we are talking about, delta theta, and say AB is the arc whose length is delta s. Okay, not straight length, but any length delta s, and this is the radius r. So you define the angle, that is delta theta here, as arc length upon the radius. I hope everybody is aware about it. So delta theta is equal to delta s by r. So if I take r here, delta s comes out to be r delta theta. This is how we write down the relation between linear direction motion and angular direction quantity. Okay, linear quantity and angular quantities just got related here. The same thing has been written here. Okay, everyone. There is a GIF file in the background. I've hidden it. It's the same GIF file which you were seeing in the previous slides. So guys, what I do, delta s is equal to r delta t. That's good. So I will divide both the sides by the factor of time, delta t. What's the benefit that I get? This thing gives me the value of linear velocity of the body, that is v. And on the right hand side, r delta theta by delta t, and we all know what is the delta theta by delta t value. That's nothing but your angular velocity. So we just now got a very beautiful and very interesting and very important relation. That is correlation between linear velocity of the body and the angular velocity of the motion. Okay, that means whenever the body will now be seen while it is performing circular motion. Okay, keep your understanding broad enough. Okay, whenever the body will be moving in a circular manner, you can actually define two types of velocities for it. One, which is along the straight line path, or as you can see that the body is not actually moving in straight line path, it is continuously changing its direction. So you can define its linear velocity for small displacements, the small displacements that the body is covering. And for those small displacements, the linear velocity can be said to be moving along the small path. If you look at it from the entire path perspective, which is a circle, you try to define its angular velocity, the rate at which the angle has been covered by the path which is taken by the body. Okay, guys. So body is going to have two types of velocities, and we are correlating them. Final correlation that you see looks like v equal to omega into r, and vectorially it is defined as r cross omega. How does that come out to be? Let me give you the understanding from cross product for that also. It is basically the result of cross product that you see on this hand right now. Okay, sorry, this GIF file is actually very heavy because of which the cursor is moving very slowly. Okay, everyone. That's why I'll be taking it to the next page so that I give you guys this very good, easy understanding on it. So people, let's have a look at this. We'll understand how that cross product is coming out or how it is working. So people, let's talk about a point where the body is here, this point. And here, let me try to trace its linear velocity. This is the linear velocity of the body, v. And the angular position, or rather the radial position of the body, this is the radial vector. This is r vector. So right now, there are three vectors which are perpendicular to each other. R, v, and omega. These are three mutually perpendicular vectors. Let me bring them simultaneously at a single point. Okay, so pay attention to this part. This is omega. This is r. Sorry, same color I will use as it is in the diagram. This is r, and this is v. Okay, people. And we are trying to understand it from three-dimensional perspective. I hope you guys are able to see the three dimensions here. There are three different axes. One is along r, one is along v, one is along omega. Means if you are not able to define its angular velocity, the rate at which the angle has been covered by the path which is taken by the body. Okay, guys. So body is going to have two types of velocities, and we are correlating you try to define its angular velocity, the rate at which the angle has been covered by the path which is taken by the body. Okay, guys. So body is going to have two types of velocities, and we are correlating them. Final correlation that you see looks like v equal to omega into r, and vectorially it is defined as r cross omega. How does that come out to be? Let me give you the understanding from cross product for that also. It is basically the result of cross product that you see on this hand right now. Okay, sorry, this GIF file is actually very heavy because of which the cursor is moving very slowly. Okay, everyone. So that's why I'll be taking it to the next page so that I give you guys this very good, easy understanding on it. So people, let's have a look at this. We'll understand how that cross product is coming out or how it is working. So people, let's talk about a point where the body is here, this point. And here, let me try to trace its linear velocity. This is the linear velocity of the body, v. And the angular position, or rather the radial position of the body, this is the radial vector. This is r vector. So right now, there are three vectors which are perpendicular to each other. R, v, and omega. These are three mutually perpendicular vectors. Let me bring them simultaneously at a single point. Okay, so pay attention to this part. This is omega. This is r. Sorry, same color I will use as it is in the diagram. This is r, and this is v. Okay, people. And we are trying to understand it from three-dimensional perspective. I hope you guys are able to see the three dimensions here. There are three different axes. One is along r, one is along v, one is along omega. Means if you are not able to see this very easy, this is r vector. So right now there are three vectors which are perpendicular to each other. R, v, and omega. These are three mutually perpendicular vectors. Let me bring them simultaneously at a single point. Okay, so pay attention to this part. This is omega. This is r. Sorry, same color I will use as it is in the diagram. This is r, and this is v. Okay, people. And we are trying to understand it from three-dimensional perspective. I hope you guys are able to see the three dimensions here. There are three different axes. One is along r, one is along v, one is along omega. Means if you are not able to see this very easy, then try to visualize this as x-axis, this as y-axis, and this as z-axis. So right now this point is the origin. And people, now try to do r cross v. I hope you people remember cross product. By cross product, when we used to write a cross b, it used to mean rotate vector a towards vector b by using your right hand. So try to curl your fingers in such a way that your r vector is trying to move towards vector b. So your thumb will be pointing upward. So that is why right now a is vector r and b is vector v. That is also valid, right? But if you try to also talk about v equal to r cross omega करना, just a minute. फिर मैंने कुछ गलत लिखा हुआ है पिछली वाली स्लाइड पे. Just a second, guys. There is one correction here. It will be omega cross r. Let me correct it and I'll show it to you in the diagram also. Just a second, guys. This slide is actually taking a lot of time to load. So this is going to be omega cross r. And now we'll look at it from this perspective. Fresh perspective, everyone. Try to rotate vector omega towards vector r. Try to rotate vector omega towards vector r. This is how the sense of rotation will be. Try to imagine omega vector coming towards r, rotating. So in that sense, try to curl these fingers. Thumb is pointing towards x-axis. Okay, another example I give you. I give you another example, guys. I will try to draw something which will be easy for you to visualize it. Okay, so everyone, this r vector, if I try v vector, velocity vector, I try to trace it here, then the vector is actually going inside. It's very difficult to show it here, but the vector is actually going inside. This vector is going inside. So if I just look at omega and r, okay, I'm removing this v vector so that we are actually able to do this practically. Everyone, try to now with me, everyone. Removing this v vector so that we are actually able to inside. V vector, velocity vector. Give you another example, guys. I will try to draw something which will be easy for you to visualize it. Okay, so everyone, this r vector, if I try v vector, velocity vector, I try to trace it here, then the vector is actually going inside. It's very difficult to show it here, but the vector is actually going inside. This vector is going inside. So if I just look at omega and r, okay, I'm removing this v vector so that we are actually able to do this practically. Everyone, try to now with me, everyone, try to do this. Try to rotate omega vector towards r. This omega vector, try to rotate it in clockwise manner. Curl your fingers in that sense. It's basically a clockwise sense. So by right hand, try to curl your fingers, the thumb will be pointing inside. That is what is suggesting omega cross r. This gives you the direction, which is the direction of v. Okay, everyone? Make sense? To all of you, you can try this at any point. You can try this here, you can try this here. You'll have to locate velocity, you will have to locate the radius vector. Okay? Awesome, thank you. Switching off the chat so that we now move a little towards the problem solving of it. Okay? Yeah. Cool. So guys, let's have a look at some examples quickly. This one, it says that a particle is revolving in circular path. It completes first 1/3 of the circumference in 2 seconds. Okay. While the next 1/3 will be covered in 1 second. Okay. That means if I talk about the circle, then in the circle, if this is where it starts from, okay. If I try to trace the body's motion and try to divide it into 1/3. So this is 1/3, and this is the 2/3 part of it. What will be this angle? What will be this angle? Can anyone tell me? What will be the 1/3 angle? In the chat box. 120 degree. And in radians, if I have to say, can I say it is 2 pi by 3? 2 pi by 3. The remaining also 2 pi by 3. And the last one is also 2 pi by 3. So body goes from A to B and then B to C. The time taken to go from A to B is how much? 2 seconds. The time taken to go from B to C is how much? 1 second. Right, everyone? So what is the total displacement? Angular displacement. Okay, what is the total angular displacement? 2 pi by 3 plus 2 pi by 3. Can I say 4 pi by 3? Everyone agrees with this? 2 pi by 3 plus 2 pi by 3. That is 4 pi by 3. Time is already known, 3 seconds. So what is the angular average velocity? 4 pi by 3 divided by 3 seconds. So what do I get? 4 pi by 9 radian per second. That's the answer to the question also. Everyone. Understood? Easy? Make sense? Kya baat hai? Bahut badhiya. Awesome. Okay. Next question, everyone. A particle is moving in clockwise direction. Now let's see how much of vectors do you people remember. Read the question. It has given us the velocity vector. It has given us the velocity vector 3 I cap plus 3 j cap, and this is the path which is traced out by the body, and the body is moving in clockwise manner. 4 quadrants are being shown. Question is asking us, as per this velocity vector 3 I cap plus 3 j cap, if you try to trace the body's location with this velocity vector, if you try to trace the location of the body, let's see. This is something which is ahead of its time kind of question for you right now, but I will still give it a shot. I'll give this question for you people to try. It's more of a conceptual question. Try to plot this vector 3 I cap plus 3 j cap as a velocity on the circle which is there in front of you, giving you all 45 seconds. Try to locate in which quadrant the body is, 1, 2, 3, and 4, and your time starts in 3, 2, and 1. Okay. Majority of the people thought that the answer is option B. Why did that happen? Is because when we try to draw this vector on the normal quadrants, we find this vector to be 3 I cap and 3 j cap. Correct? This is I cap. This is j cap. So the vector looks like a vector which is in the first quadrant. Yes, that's what it is. But everyone, the body's velocity will be represented on the body. And this is not any random circle. This is the trajectory of the body. You have to actually take this velocity vector and put it on the body. Okay. So now let's try to fit this with the sense of motion that the body has, clockwise sense. Let me take a vector which looks like this on the first quadrant. Do you think this is the velocity direction of the body? Nah, body is not heading towards that direction. You know that the body is actually heading in this direction when you're talking about the first quadrant. I hope the mistake is clear. That is not the first quadrant. So sir, let's try to plot it on some other quadrant. Let's try to plot it on the fourth quadrant. We are going to plot only this vector. This is the vector that we are plotting at different locations. So body is going in the clockwise manner. Is it on the fourth quadrant? Doesn't look like it because the body is heading towards this direction. The body is trying to go towards the third quadrant. So this velocity vector is not suggesting that. Let's try to plot this for the third quadrant. Does it look like body is heading in this direction? Nah. So let's try to put it on this direction. I hope this is making sense to all of you. This is the velocity vector. Guys, make sense? This is something which is more than my words, should be visible in the diagram. Right? Aaya samajh mein? You have to actually draw the velocity vector on the body. Okay? Is that clear? Cool. Perfect. Khatarnak question. Aryan, you have to represent the velocity vector with the body's location. So body, if it is located at first quadrant, it is actually heading in this direction, which is not as per this velocity vector, the velocity which has been given. That's why. Fourth quadrant mein body is actually heading opposite to that direction. Fourth quadrant mein body is heading opposite to that direction because body is going in clockwise manner. Agar yahi body anti-clockwise move kar rahi hoti, fourth quadrant answer hota. Okay? Okay? हाँ, अगर anti-clockwise होता, if that would have been an anti-clockwise direction motion, then the answer would be fourth quadrant. Okay? Exactly, Aryan. उसके sense of rotation से देखना है. बिल्कुल, हाँ विहान. Sense of rotation से देखना है, जज करना है. Cool, awesome. मानस ये डायग्राम देखो, ज़्यादा अच्छे से समझ में आएगा. On all the four quadrants, where exactly the body is heading to, these are actual velocity vectors, and you are looking for a velocity vector which looks like this. So the one which resembles is the quadrant that is 2. Okay. Good evening. मतलब जो सर्कल पे बनाया है या जो वेक्टर में बनाया है? प्रोजेक्टाइल मोशन अंकन का याद है? तो प्रोजेक्टाइल मोशन में जब हम ऐसा मोशन दिखाते थे तो अलग अलग पॉइंट्स पे वेलोसिटी वेक्टर कैसे ड्रॉ करते थे, मानजन बनाते थे, ये पॉइंट पता है. तो सर्कल में भी वही होगा. अब बॉडी सर्कल में मूव कर रही है और बॉडी जा रही है क्लॉकवाइज मैनर में. क्लॉकवाइज समझ में आता है? ठीक है, तो बॉडी क्लॉकवाइज मूव कर रही है और ये मेरा क्वाड्रेंट बताया हुआ है मुझे स्मैश मोशन के अंदर, क्वेश्चन के अंदर. तो अगर मैं चारों क्वाड्रेंट्स में बॉडी के वेलोसिटी वेक्टर्स को रिप्रेजेंट करूं तो बॉडी जब सेकंड क्वाड्रेंट में है तो तुम देखो ये उसका रेड वाला वेक्टर वेलोसिटी वेक्टर होना चाहिए टैंजेंट. जब बॉडी फर्स्ट क्वाड्रेंट में है तो ऐसा वेलोसिटी वेक्टर होना चाहिए, दिस शुड बी द वेलोसिटी वेक्टर. इफ द बॉडी इज इन फोर्थ क्वाड्रेंट दिस शुड बी द वेलोसिटी वेक्टर टैंजेंट. एंड द लास्ट वन इज दिस वन. एक्चुअली देयर आर इनफाइनाइट नंबर ऑफ वेक्टर्स व्हिच आई विल हैव टू ड्रॉ एट डिफरेंट पॉइंट्स, बट ब्रॉडली रिप्रेजेंट करने के लिए चार मैंने कंपोनेंट्स बता दिए या चार डिफरेंट वेक्टर्स दिखा दिए. ठीक है. नाउ एज पर द क्वेश्चन वी आर लुकिंग फॉर अ वेलोसिटी वेक्टर व्हिच इज 3 I cap plus 3 j cap. Right? So if you try to represent this vector, this is the only vector which is resembling 3 I cap plus 3 j cap. एक वेक्टर को उसके ओरिएंटेशन को चेंज किए बिना अगर मैंने उसे डिस्प्लेस किया तो वी से दैट द वेक्टर इज नॉट चेंज्ड. सो द वेक्टर दैट मोस्ट ऑफ द पीपल आर कॉलिंग टू बी द फर्स्ट क्वाड्रेंट वेक्टर, द वेक्टर इज एक्चुअली फर्स्ट क्वाड्रेंट वेक्टर फॉर एवरीवन. वेक्टर एक्चुअली फर्स्ट क्वाड्रेंट वेक्टर है 3 I cap plus 3 j cap. पर क्वेश्चन ने क्या बोला है? क्वेश्चन ने पूछा वेयर एग्जैक्टली द बॉडी व्हिच हैज दिस वेलोसिटी लाइज इन. जिस बॉडी की वेलोसिटी फर्स्ट क्वाड्रेंट का वेक्टर है वो बॉडी खुद कहां पे है, ये पूछा है क्वेश्चन में. गेटिंग? सो वेलोसिटी वेक्टर जो है वो फर्स्ट क्वाड्रेंट वाला वेक्टर यही है. दिस इज एक्चुअली दैट वेलोसिटी वेक्टर. गेटिंग? यस, बट द बॉडी इज इन सेकंड क्वाड्रेंट. ओके. Okay people, quick question for all of you. You have to find out the angular velocity of rotation of the earth about its own axis. Information will not be shared. You have to figure out the information about it. But yes, I will give you people 60 seconds to think about it, and your time starts in 3, 2, and 1. And I will also give you one more information. Earth, its angular speed is constant. Its angular speed is constant. That's why every day The duration of the day is 24 hours. Okay, guys. So how many number of seconds are there in one day? And how much angle does the Earth rotate in one day? By how much angle the Earth rotate in one day? I'm talking about Earth ka rotation, not revolution. Around Sun, I'm not talking about its own axis, right? So if we try to find out the angular velocity of the Earth, it is the angular displacement divided by the time taken, right? If it has to cover 2 pi angle, the time that it takes is 24 hours, right? But if you will think of this as the answer, then the units will actually betray you. The units are not per second then. Then it is 2 pi radian per hour per hours, yes. Okay, so you will have to actually convert it into seconds. Pranav Sanyal, next time you copy paste that and I block you. Nonsense stuff will not be tolerated on the chat box. Pranav Sanyal, अपने मन की भड़ास मत निकालो चैट बॉक्स पे, okay? Or have the guts to have microphone to talk to me, okay? Applicable on all of you. So 24 hours, every hour has 60 seconds, and every hour has 60 minutes, and every minute has 60 seconds. So this is one way of calculating the number of seconds in a day. The other way of calculating the number of seconds in the day is wake up whichever time you wake up at. Say you wake up at 6:30, sit with a stopwatch then, and just look at the watch. Do this just for 24 hours. You'll be able to come to a conclusion that there are 86,400 seconds in a day, and you will be amazed then. Okay, so 24 by 86400 seconds gives you, sorry, 2 pi. So this will be 2 pi by 86400 radians per second, the angular velocity. Okay, shall we try in JEE? बिल्कुल बिल्कुल, IIT जाके कर सकते हो ऐसा. Okay, cool. चलो everyone, switching off the chat once again so that we focus. Switching off in 3, 2, and 1. Okay, so everyone, next quantity that we try to define is called angular acceleration, and if you understood angular velocity and angular displacement, you'll be able to understand this also very easily. Goes on the lines of acceleration only. Try not to look at the diagram, try to understand what I'm speaking. Just like acceleration used to tell us how fast the speed is increasing or how fast the speed is decreasing. That means what? Acceleration used to come into picture when the velocity was changing. So here angular acceleration will come into picture when angular velocity will change. And by the way, if you want to really experience this part, you can switch off the fan right now in your house. Switch off the fan. You will be able to experience the change in angular velocity. You will see the fan speed slowing down. Okay, and if you want to increase angular acceleration, that will be angular retardation, the first one. If you want to acceleration, if you want to experience angular acceleration, switch on the fan. Then you will find that angular speed of the fans will increase. Getting? Exactly. So everyone, so that is what is angular acceleration. But after some time, by this time, if your fan now doesn't seem to be accelerating, it has achieved a constant angular velocity. Or if you have stopped it, it will stop and will have 0 angular velocity. Okay. Yes, Vihan. Whichever way, you have to just increase or decrease the angular velocity. Okay, everyone got the basic idea. It's same as that of linear acceleration. It is only with respect to angular velocity. Similarly, for instantaneous small time of displacement, it's basically d omega by dt. You can switch on the fan once again, everyone. Okay, now people, before I tell you the direction of angular acceleration and explain it, let me give you the correlation again. When we used to speak about a body which is moving on a straight line, say this is the direction of its velocity. So people, in order to increase the velocity of the body, we need to apply the force on the body in the same direction. You remember? If in order to increase the velocity of the body, we need to apply the force in the same direction, and acceleration and force have the same direction. So can I say that acceleration will be along the same direction if velocity is increasing? Yes, everyone. It's important conclusion. If velocity is increasing, then the velocity direction and acceleration directions are same. But if the velocity of the body, say if the velocity of the body is decreasing, then to decrease the body's velocity, in which direction will you apply the force? You will apply the force in the opposite direction. That means what? That is the direction of the acceleration also, which actually is not called acceleration then. What do you call it? Then it's called retardation. So okay. Same applies in angular motion also. If angular velocity is increasing, this is the sense in which your body is moving, that is anti-clockwise. And if omega is increasing, so angular acceleration in the same direction. But if omega is decreasing, then opposite direction. Got it? Perfect. Awesome. Now there are again 3 types of possibilities. Switching off, 3 possibilities of circular motion. 3 possibilities of circular motion that will encounter. Broadly, there are 2, but the second category is further divided into 2 categories. This flowchart you have seen in kinematics with me. Okay, so circular motion could be uniform or could be non-uniform. A uniform circular motion will be the one where angular velocity of the body will be constant. Okay, and non-uniform when angular velocity of the body is not a constant. Okay, and when angular velocity is not constant, that means it is changing. And whenever angular velocity changes, acceleration comes into picture. So non-uniform circular motion is also called as accelerated circular motion. So then there are 2 possibilities. I hope you people remember this. The first one is called uniformly accelerated circular motion. Okay, circular word I'm not writing, too much of writing for that, so you will understand, right? The third one will be non-uniform infinitely accelerated motion. So this one is when your alpha is constant. Okay, and this one when your even alpha is not constant. So which are the three different motions that we study? First one, or other we'll encounter. Second one, and third one. Achha, in these three, where will you use calculus? Where will you require to use calculus? Out of these three, exactly. The third one is the one that you're studying in 11th standard. Where is the axis? Where will you use those three equations of motion? Where will you use those three equations of motion? V equal to u plus at, s is equal to ut plus half at square type of motion equations, right? Actually, you can use it in first also, but those are actually required in the second one. So remember, the second one will be having this type of equations. Everyone, you have omega naught as initial angular velocity. Omega is final angular velocity. सर घर के बाहर कोई है, मेरे घर के बाहर रोड है और वहां पे कार है, ओके? और इतना तो कॉमन सेंस लगाओ कि अगर तुम्हें सुनाई दे रहा है तो मुझे सुनाई दे ही रहा होगा. थीटा इज एंगुलर डिस्प्लेसमेंट. ओके, मैं इक्वेशंस नहीं पढ़ रहा हूं, मुझे समझ में आ रहा है, तुम्हें भी समझ में आ रहा होगा. दीस आर द थ्री इक्वेशंस ऑफ मोशन व्हिच विल बी एप्लीकेबल ओनली व्हेन एंगुलर एक्सेलरेशन इज कांस्टेंट. ओके, बाय द वे, व्हेन योर फैन इज स्विच्ड ऑन, okay, by the way, when your fan is switched on, it actually accelerates uniformly. It will cover equal, its velocity will change by equal amount in equal intervals of time, and then it achieves a constant angular velocity. Okay, good. Yes, Aryan. This one. इसके पहले वाला, ये वाला. All the three quantities, theta, omega, and alpha, all the three quantities are perpendicular to the circular path. जो सर्कल जहाँ पे हुआ है ना, बॉडी जहाँ घूम रही है, उससे perpendicular है तीनों quantities. Okay. Now, ठीक है, guys. Let's have a look at an example also, switching off the chart so that we focus on the screen. Question says that the angular velocity of the particle is given by omega equal to 1.5t minus 3t square plus 2. Find the instant when the angular acceleration becomes 0. Yeah, ये question मैं तुम्हें दे रहा हूँ directly, guys. I'm giving you people this directly. Only thing that I'm telling you, all of you, alpha is d omega by dt. That's what it is. जैसे a होता था dv by dt, linear acceleration used to be dv by dt, angular acceleration is d omega by dt, और इसको 0 से equate करना है तुम्हें, और वो कितने टाइम पे ऐसा होता है. You have to find out the value of t. And everyone, I'm setting up this as a quiz. Your time for 45 seconds starts in 3, 2, and 1. Come on, quickly, बहुत जल्दी होना चाहिए. Okay, and the time is up. Simply differentiate and equate it to 0. Let's see. Decent number of people got this right, at least percentage wise I can say that. Okay, so everyone, if you want to differentiate this equation, that is 1.5t minus 3t square plus 2, then d omega by dt, which we also find as alpha, will be 1.5. Okay, 1.5 remains as it is. Differentiation of t is 1, minus 3, differentiation of t square is 2t, and differentiation of 2 is 0, because that's a constant, and this will be equated to 0, because question is asking us the instant when the angular acceleration becomes 0. So alpha equation is in front of you, and that has to be equated to 0. So I have 1.5 minus 6t equal to 0, or you can say 6t will be equal to 1.5, or you can also write it as 3 by 2. So t will be equal to 3 by 2 into 6, that is 1 by 4, or 0.25 seconds. Okay, so that's our answer, option C. Okay. Now this one is an example I will do. This says that the disk starts from rest and gains an angular acceleration which is varying with time. So alpha is not a constant here. 3t minus t square. So calculate the angular velocity after 2 seconds, and obviously it is starting from rest. So if I want to find out the change in angular velocity, just again this follows from the kinematics, that differentiation of velocity gives you acceleration, and integration of acceleration gives you the change in velocity. Okay, so integration of alpha dt going from t equal to 0 to t equal to t will give me the value of angular velocity ka change. Okay, so thing is, final angular velocity minus initial angular velocity will be integrated from 3 as in 3t minus t square is what alpha is into dt, and time is going from 0 to 2 seconds. Initial angular velocity has been given 0, and final angular velocity is being asked. So integration of 3 into t. So t ka integration will be t square by 2, and minus t square ka integration will be t cube by 3, going from 0 to 2. So you will have to put the limits: 3 by 2, 2 square, minus 2 cube by 3, and everything after putting 0 will be 0. Plus c I don't need to write because that is a definite integration that we are doing. So 4 into, this is basically 4 by 2, so this is 6 minus 8 by 3, or we can say 18 minus 8, 10 by 3. So 10 by 3, option D is the correct answer. That way. Okay, everyone. If you are finding the integration part confusing, then you need to actually revise. As I've said this, like during the chapter of work power energy only, I told you guys to do a thorough revision, watch the replays of vectors, integration and differentiation. Very important. Okay, so a question for all of you. Question says that if the equation of the displacement of the particle moving on a circular path is given as 2t cube plus 0.5, and theta is in radians, t is in seconds, you have to find out just the angular velocity at t equal to 2 seconds. How much will be the angular velocity? Okay, from the start obviously. So giving you guys 45 seconds, it doesn't deserve more than that, and your time starts in 3, 2, and 1. Come on, guys. $20 seconds remaining. Last 5 seconds. Time is up. So everyone, if we find out omega, that is d theta by dt. So just differentiate this equation. So 2 remains as it is. Differentiation of t cube is 3t square. Differentiation of 0.5 is 0, and this comes out to be 6t square. And at t equal to 2 seconds, this comes out to be 24 radians per second. That's the answer. Okay. Okay, guys. Now the third part of the topic, and again something which is little twisted, little confusing at times for many students. So try to focus on the screen when I'm explaining this. It's a real important topic also. Its importance will be reflected when you actually solve questions which are of JEE main and above level. Okay, very easy questions are not going to be challenging, but once when you start solving good level of problems, you will actually require good clarity on the difference of the two types of acceleration that you see here. Okay, so we have already talked about angular acceleration. Angular acceleration is basically for the angular velocity. Now we are coming back. We are taking a step back and we are speaking about the linear acceleration once again. Yes, the linear acceleration. And linear acceleration will have two components. One will be called radial acceleration, the second one will be called the tangential acceleration. Okay, so before I actually tell you what are radial and tangential acceleration, I need to give you a quick recap of something called as the multiplication rule. And obviously, multiplication rule was studied when we were speaking about differentiation. So if you have two quantities which are multiplied and you want to find out dy by dx, okay, so if you want to differentiate, then differentiation of one of the quantities is done, the other is kept as it is. That means u dv by dx plus v du by dx. So koi yaad hai? Everyone remembers this, called as multiplication rule of differentiation. If you don't remember this, you need to do a thorough recap by watching my sessions, the replays of that. I have taught this during the chapter of kinematics. In kinematics, we probably have done this in session number 5 and 6. Kinematics session 5 and 6, we have done this. Okay, not 100% sure, but somewhere around that. Do I need to come to your screen and then actually touch yes or no? Quickly do that. Thank you. Ending the hotspot. So everyone, something of this sort will be required in some time. So coming back to what we are speaking about as radial and tangential acceleration. So let me first tell you what exactly is a radial thing. What is a radial quantity? A quantity which is along the direction of the radius. That means what? If you start from the center of the circle and if you start moving along the radius, so this becomes the radial direction at point A. For any other point, the radial direction will be different. Like wherever you trace the radius, wherever the body actually is on the circle, you just trace its location. For B, this is the radial direction. That those dotted lines that you see that I'm drawing, that entire path is the radial direction. Okay. On this path, any vector that will come will be called as a radial vector. Okay. And I hope tangential is something that you guys are very well aware about. But tangent is basically drawn in such a manner that it just touches the circle, right? So any vector that will come on this line will be called as the tangent. So a vector, an acceleration which is along the radial direction will be called as the radial acceleration. An acceleration which is on the tangential line will be called as tangential acceleration. Visualization model physically.